Okay, this is a video for pre-algebra. We're talking about exponent rules in this unit. And I'm going to move this over here. And what our goal here is in this video is to talk about the definition of an exponent and how to expand and simplify expressions. So first of all, for our definition of an exponent, we've got a couple different key terms here that we want to talk about. We have the base here, which is my number that is going to have the exponent. And so the exponent is this kind of superscripted number. The whole entire thing here is called a power. And so over here we're talking about some definitions that you'll want to write down. So go ahead and hit pause and write these down, and then when you hit play, we can talk about them. So the base is the number that is being multiplied, and that's, in this case, the 2. The exponent tells us how many times the base is used as a factor, how many times we're going to multiply 2 times itself. So notice over here that my exponent is a 4, and that tells me to multiply the base, which is 2, times itself 4 times. So I notice that right here there are 4 2's, and that's my exponent. Now the number that can be expressed using an exponent is called a power. And so this whole entire thing, 2 to the 4th power, is how we would say this. So what does an exponent mean? An exponent means repeated multiplication. So as an example, x to the 3rd here is going to mean x times x times x. Again, that base times itself 3 times in this case. So as we look at a couple of examples here, it says write the repeated multiplication as an exponent. So what I want to look for in these scenarios is how many times I have the same exact thing being multiplied times itself. And so I'm going to write that base, and I'm going to keep it in parentheses because it has parentheses here for each term. And I notice that there are 6 of them. And so for my repeated multiplication, I know that I have 8r as my base. There are 6 of those terms that are exactly the same being multiplied together. And so I have 8r to the 6th power. So here's an example. Go ahead and take a look at this guy once. And even though it looks a little bit trickier, notice that every term inside of the parentheses is exactly the same, and there happens to be 4 of them. So for the time being, a simplified version of this as an exponent would be m cubed n squared, all of that to the 4th power, because there are 4 of these terms here that we are multiplying. So then we're also going to talk about working backwards, where we write the power as repeated multiplication. So just as a refresher, remember that when we said x to the 3rd is the same as x times x times x, in this piece we notice I have my base, and I know how many times I am multiplying it times itself. So I would have 3x times 3x times 3x times 3x. So I have that piece being multiplied 4 times. This one is just a little bit different because notice that there are no parentheses in this problem. So my exponent of 3 here is only being applied to the w. It has nothing to do with the 6, because this is the same thing as saying 6 times w to the 3rd. And so the only piece that has the cubed exponent here is the w. So the 6 is going to sit there and not change, and now I'm going to have w times w times w. Okay, lastly, we've got a whole bunch of stuff happening here inside of my parentheses. And so I've got 5w to the 3rd z. And I'm going to take that thing times itself, 5w to the 3rd z. So I have 2 of these pieces here, 2 of these pieces, an exponent of 2. If I wanted to go one step further, because I still have an exponent inside of each of parentheses, I could go one step further and write this as 5 times w times w times w times z times 5 times w times w times w times z, and now I have no exponents left whatsoever. I have used my definition to expand everything out. So I hope that helps clarify some issues that we may have had in the past about what a definition of an exponent is and how we can go from repeated multiplication in terms of writing an exponent, but we can also go from something that is multiplied out and write it as an exponent as well.